Hello everyone, welcome to the another important session in which we will be discussing some more important concepts and some more important questions related to transistors. So I hope that the discussion which we will be doing today in this session will get clear to all of you. And since transistor is a very important topic, so everybody needs to know about the important concepts related to transistor topic for the upcoming CSIR NET and the GATE exam, and even for the other similar exams. This topic will be helping you to solve the related questions and to know about the most important concepts as well. So guys, we will soon be starting the discussion about all these important points, but before that I'm gonna share an important update with all of you, that is regarding the Unacademy subscription. So soon there can be the price hike on the Unacademy subscription we are having for different duration. So basically, if you want to start attending the live classes by the top educators we are having on Unacademy Plus for the upcoming exam preparation, or even if you want to take the iconic subscription, then you can take the subscription before there will be the price hike, and by taking the subscription you will be able to start attending the live classes of well structured and well planned courses by the top educators we are having on Unacademy. Also guys, by using and by applying the referral code which is Anjali A Live, or even if you know about the referral code Anjali Arora, you can get the 10% discount in the total Unacademy subscription amount by using and by applying the referral code. Even I would like to show you one more thing here, that is what are the benefits you will get if you will take the plus or the iconic subscription. So all the benefits have been shown here. If you will take the plus subscription, you will get these benefits. If you will be taking the iconic subscription, then you will be getting these benefits. So this is how by taking the plus or the iconic subscription you will be able to start attending the well structured and well planned courses by the top educators, and you will be able to take your preparation to the next level under the guidance of top educators. Even the subscription is available for different duration, for example 3 months, 6 months, 12 months, 24 months, and for different duration. So you can check that in the Unacademy learning app. And if you want to take the Unacademy subscription, for that what are the steps you can follow, I'm just going to tell you that. So basically guys, you can first of all download the Unacademy learning app, and after that you can select your goal, for example CSIR UGC NET, or like for any other exam if somebody is doing the preparation, that's what you have to select as goal. Other than that, what you have to do next, that's gonna be you have to select for how much time you want to take the subscription and which subscription you want to take, whether you want to take the plus subscription or the iconic subscription. And after that you can just proceed further. You will get a place to write the referral code. There you can write the referral code Anjali A Live, apply the referral code, and at the same time you will be getting the 10% discount in the total subscription amount. So this was something important I wanted to share with all of you. And now we are ready to talk about the important topic which we will cover up in this session today, and that is transistor. I hope even you all are ready for that discussion, but in case at any point of time if you will be having any doubt anywhere, then you can surely mention it in the comments and we will try to consider that point too. Okay guys, so we will be continuing the discussion now, and we will talk about the important topic, that is transistor, today in this session. One more thing, even if you will have any doubt anywhere at any point of time, then you can just mention it. I'll be talking about that too, otherwise in very easy manner, in such a way that everybody will be getting each and every point I'll be discussing, okay, in the session. So that's how we'll be continuing the discussion, and we will talk about all these important points in the session today. So mostly students say that they find this topic quite difficult, they are not having any idea about it, or even they study the topic, still they are confused about it. So what we will try to do in this session, we will try to make the basics clear first of all, and after that we will be trying to consider the other points, for example the most popular expressions related to transistor, and we will see that how like all the concepts will be working, and we can use different concepts in this topic and to solve the related questions too. Okay, that's what we will do. And at any point of time, if you will have any doubt anywhere, what you need to do, you just need to check that in, like, you just need to mention it in the comment section. I'll be considering it then. Clear? So let's continue the discussion and let's talk about it. So basically guys, when I'm going to talk about the transistor, do you know anything about it? If yes, just mention it in the comments too. Okay, and if you don't know, I'm gonna just explain it. So basically what we will be considering as a transistor. So if I want to say something about the transistor, I can just say different points about it, because like there we are going to have some of the points in transistor. Can you say something? I'll just wait for your comment. Okay, first, and after that I am going to tell you what you can consider regarding the transistor. Okay, I am going to tell you for sure, but before that let's even consider it as a discussion, and after that we'll be continuing that too. Very good evening Gaurav, very good evening everyone. Okay guys, so till that time you are gonna mention something in the comment section. I'm even gonna tell you that what you can consider about the transistor. So the first thing is, you may be familiar with this point that we are going to have two types of transistors. That is NPN transistor is there, as well as PNP transistor is there. Okay, NPN and PNP. So how we form the transistor, that's the first thing. Okay, because if you are gonna consider something and you will consider that topic as a story, so it will get more clear to you, and if you are understanding it in such a way that you are ready to explain it to anyone, means the understanding with the topic is very well, and you are going to get everything clearly. And even anytime if you have to tell something about the topic to anybody else, it will be quite simple and easy for you to do it. Clear? So NPN or PNP type transistor. Now how you are going to construct that? You know about the semiconductors, N type, P type. Okay, these are the different semiconductors we will have. So after doping, depending on what are the majority charge carriers we will have there, we will be considering the particular type of semiconductor as N type or P type. Clear? Other than that, you can see it's a kind of sandwich. Instead of two breads, you are gonna have either N type or P type in two different cases. And inside the breads, instead of filling some stuff which you can eat, you are gonna fill the P type or N type in between. That is the opposite type. Clear? So by sandwiching one type of semiconductor, that can be P or N type, between the opposite pairs of semiconductors, you are gonna form a transistor. It can be NPN transistor or it can be PNP transistor. Is that clear to everyone? I hope yes. Even you can see in a transistor, and even if you are gonna have any doubt, just mention it. In a transistor we can have the two PN junctions. So basically if you will see this one, the NP, it will have a junction. On the another one, it will have a junction. So basically NP and PN, that is forming the PN junction. So how many PN junctions are there? Two PN junctions in a transistor. I hope that's clear to everyone. Clear? But still, again, at any point of time, if you will be having any doubt, then you can mention it. So that was something about the transistor we can consider, and it's very easy to understand as well. That by sandwiching, okay, one type of semiconductor between the opposite pair of semiconductors, we can form a transistor. In a transistor, we will have two PN junctions present. Clear? So I hope that's clear. How many terminals we will have in a transistor? So if I have to construct a transistor, how I will make it? So basically we show it this way, as I'm going to represent it right now. If I want to show NPN, I can take NPN. Okay, while the center part I will show little bit thin in comparison to the corner ones. Reason, I'll be just concluding after doing or taking the further points here. Okay, now so the other one we will be making is the PNP type. Clear? PNP. If you are the one you don't know anything about it, don't worry, because I'll consider everything here. Done, the basic part, the introductory part, the advanced part, and everything. So you don't need to worry about anything then. So what are the, how many terminals are there in case of transistor? There are three terminals. You can see in both cases, in NPN I have considered the three terminals, and in the PNP case I have considered the three terminals. Clear? So in the first case we are going to have 3 terminals. In the second case also we are having the 3 terminals. So basically there are 3 terminals in a transistor. But what are the different sections I have formed? You can see I have formed first section, second section and third. Once again, first, second and third. 3 sections I have formed there. But what are these sections and what we can call them? So basically this is known as ammeter. Okay, or any one of the corner ones you can call it ammeter. Same way here you can call it ammeter. Okay, the center one is known as the base. Okay, and here also the center or the middle one is known as base. The last one will be known as collector. Clear? Collector. Once again it will be known as collector. Done? So you are getting the 3 sections in a transistor. One is known as ammeter, the another one, center one or the middle one, is known as base, and the last corner one or any of the corner one opposite to the first corner you have taken, that will be considered as the collector. 3 sections. Clear? Now you may see that I have made this middle section quite thin in comparison to the corner sections. Reason behind it, that is base. Base generally in a transistor you will find it's a thinner section. Done? Means thin in comparison to the other sections we will have in a transistor. So that's okay, and that's how we represent it. Clear? Even if you will see actual transistor, you will be considering this point there, that the base is thin in comparison to the other 2 sections. Okay, let's come to the next point now. What will be the working or the functioning of the emitter and the collector we will have? Okay, how they work, what actually is the functioning of the different sections in a transistor, because there should be some idea about these things too, so that we will get to know about it, that how basically a transistor is going to work, or what are the things we will have in a transistor. To get the clear idea about it, I am just going to make it clear to you with the easy explanation, and at any point of time if there is any doubt, surely mention it, let me know about it, and I will surely try to consider that point too. So now the next thing is, guys, you can consider about the emitter. Okay, section wise we will do the discussion. That is, it will be emitting, okay, or sending or transferring, you can say anything, you are having lots of words for that, the majority charge carriers, okay, from emitter to base. So it will transfer, it will send, okay, the majority charge carriers present in the emitter towards the base. Okay, one more thing, if the majority charge carriers will go towards the base, what is the meaning of that? What is the majority charge carriers? First of all, we have to understand that thing. In the N-type semiconductor, the electrons are the majority charge carriers. In the P-type semiconductor, the holes are the majority charge carriers. So in N-type, if you will consider the movement of the charge carriers, so what will be the charge carriers which will go from one to other place? That's gonna be the electrons, because Npn. So in N-type semiconductor, electrons are the majority charge carriers, so they will move. Okay, the emitter will emit the what? Electrons. In Pnp transistor, the holes are the majority charge carriers, so it will emit the holes. I hope you are getting that. But in case if you will have any doubt anywhere, you can surely let me know about it. Clear? Now base. So base is there, it's the middle section, that's the point we are considering about the base right now. But then if the majority charge carriers have been sent from the emitter towards base, what will be the role of collector? So collector is there to collect the majority charge carriers which have been transferred from the emitter to the base. Okay, so collector will collect them, and that's how with the charge carriers movement or the motion, the transistor will be doing its functioning, or it will work this way. I hope everybody is getting that point too. Okay, in case if there is any doubt, you can tell me. Otherwise, I am going to include the next point now, that is about the connection. So as you know, in electronics, the connections are very important. What type of connections? Since you know, if you connect N-type semiconductor with P-type or P-type with N-type, okay, if you connect two, that is N and P-type, It forms a diode. What it forms? It forms a diode. When it's forming a diode, you may be familiar with the notation or the symbol representation of the diode. In this case, you can say that it is the positive side, it is the negative side. Clear? Other thing, if you connect the positive side of the diode with the positive side of the battery and negative side of the diode with the negative side of the battery, then we say that the diode is forward biased. Means same polarities have been connected together. Then we say it's forward biased. Forward biased means what? Forward biased means the diode will be conducting. Okay. While if I will connect the negative one with the positive side of the diode and the positive one with the negative side of the diode, then we will call it the reverse biased. And reverse bias means what? It will not conduct. Okay. There will be no conductivity, or you can say it will directly not be conducting. The current will not flow through it. Okay, that's the basic idea about the reverse bias condition you can have, and which will make everything clear to you. Now once you have got it, what do you have to do next? The next thing here you have to consider is about the connection. See, there is emitters terminal from the emitter side, and there is a terminal from the base side. So in that case, somewhere you will connect a battery here in between. Okay, positive terminal or negative or positive this way. But always remember that the emitter diode or emitter base diode, you can give it the name emitter diode or emitter base diode, anything. Okay, and the side one which is connected with base and collector, you will give it the name collector diode or collector base diode. Okay, so emitter base diode will always be forward biased. Now what is the meaning of forward biased? I have already explained that, the diode condition. Okay, so positive side means if N side is there, it should be connected with the negative terminal of the battery, and if P is there, then it should be connected with the positive terminal of the battery. And if it will be having the similar connections as I have talked about it, it means it's a forward biased case. So in NPN, you will consider this one as negative side and P as positive side, and you have to connect it with the same polarities of the battery. Same way here, you have to consider P type as positive, N type as negative, and you will have to connect P with the positive and with the negative side of the battery, because emitter diode will always be forward biased. Now this discussion will make it very easy for you to have a better understanding with the circuit and to know like how actually a circuit will be working, what it will be doing, okay, what you will get from the circuit. So that will make the things more clear to you this way. In case if there is any doubt anybody will have, you can surely tell me about it and I will be trying to consider that too. Okay, but if everything is clear, that's great. We can continue the discussion and we can talk about some more points now. So this was all about emitter. Even if you want, you can make some short notes if you want to note down some of the important things here. Okay, now other than this, the next point we will be considering will be, okay, one more thing. If NPN transistor is there, what emitter will emit towards the base? That is electron. If PNP transistor is there, what emitter will emit towards the base? That will be holes. Okay, the majority charge carriers. We have already talked about it, but in case still if you are gonna have any confusion, you can just mention that and we will be trying to consider that point. Okay, next thing. If I will talk about the collector diode, what is the collector diode? This PN junction which you are getting here, or this NP junction which you are getting here, we can even call it the PN junction because junction is between N and P or P and N. Then in that case, this is your collector diode. Okay, that is your collector diode or collector base diode, any name you can give it. In that case, it will be collecting the charges. Okay, it will be collecting the charges. One corner, one side is emitting the charges, the majority charge carriers, and the other one will be collecting the charges. Done, that is the collector. Now the next thing about the connections you need to know, you have already got to know about the emitter diode, that it will always be forward biased, but the collector diode will always be reverse biased. Now what is the meaning of reverse biased? when the positive, if P is there, we will assume it to be positive or consider it to be positive, because you know the majority charge carriers in the P type semiconductor will be holes. Okay, so you have to connect it with what? The negative one, because you want it to be reverse biased. So opposite polarities in the reverse biased case, but same polarities in the forward biased case. So negative and positive. This is how you have to consider it. Okay, so P type connected with negative, N type connected with positive, it makes it reverse biased. Same way, N type connected with positive, P type connected with negative will make it reverse biased. So collector diode always reverse biased and emitter diode always forward biased. That's the thing we have to consider about the what? About the transistors different sections. Okay, I hope it's getting clear to everyone, and in case if there is any doubt, you can tell me about it. One more thing you can conclude from this section, that is emitter diode, because we are considering it will always be forward biased, the emitter diode. It means it will have low or less resistance. Forward bias means more like conduction you can say, okay, or it will be conducting well. So in that case its resistance is less, while reverse bias means its resistance will be more. So that's even the second point you are gonna get from this discussion, that which side will have more resistance and which side will have less or low resistance. Okay, in case if there is any doubt, you can tell me about it. Very good evening Deepak, very good evening everyone. Now let's talk about the next thing. So there are some of the more points you need to know about the transistor. Okay, one thing I have already told you, that the base is the thinner section in comparison to the emitter and collector. The base is the thinnest one you can say. Okay, if we will say the emitter and collector, so what about them? The base is the thinnest one, that's great, we got to know about it. It's the smallest or the thinnest section we will have. But what about the emitter and collector? Out of the other two, is there like they are gonna be equal, or there is another one which is wider than other one, or which is the widest one? So is there anything like that? So if you know, you can mention it in the comments. If you don't know, I'll be telling you. I'm just going to check out the comments. Do you know what will be the after base? Means after base second number, and then last one will be the widest, the greater than other two. Any idea anybody is going to have? Even you can get this type of questions in the exam, and for that you should have clear idea about this thing, that which is the largest section. Very good Shubhankar, that's great. The collector is the wider than the other two. Okay, collector is widest one you can say, okay, or wider than the emitter and base. Collector, that's the answer. While emitter will be having the like area covered, or you can say the section in the emitter case, which is in between the base and the collector. Okay, so base thinner than emitter and collector, collector wider than emitter and base, means wider than other two. Okay, and emitter in between base and collector. I hope it's clear. Even you can expect a question from this section as well, that which is the widest section, which is the thinnest section. Okay, and that is the point from where you can expect some question in your exam. Now there is one more point. Which section is the heavily doped section in comparison to others? Which section is the heavily doped section? Can you please let me know if you know about it? Heavily doped section. Heavily doped section. Emitter, base or collector. Which one is the heavily doped? Very good Shubhankar, that's great. What about others guys? Even if you know about it, you can just mention that. Which section is the heavily doped section? What about others? Just mention it if you know about it. If you don't know, I'll be telling you then. So already Shubhankar has mentioned it, that emitter, and that's correct. Ammeter is the heavily doped section, while base is lightly doped section, and collector is moderately doped section. Ammeter heavily doped, base lightly doped, collector moderately doped. Okay, so this is how you can consider in terms of doping. Ammeter heavily doped, base lightly doped, and collector in between both of them or moderately doped. I hope it's clear, but in case if you will have any doubt anywhere, just mention it. I'll be considering that too. And if you are getting everything clearly, that's great. Done? Clear? Okay, once you are getting to know about all these things, I would like to show you the other figure corresponding to which, like, we will be taking the symbolic representation of transistor, and we will be considering important equation or like relation between the ammeter, base and collector current. So further we will be starting the derivation part from here. Okay, but before that I need to introduce the that symbolic representation first of all, and then we will be proceeding further. Excuse me. And I will even share an important point here which will help you to easily identify which one is the NPN type or which one is the PNP type. There is a unique way you can consider to identify that thing too. Okay, so what will be that? We will talk about it. Okay, in case anywhere if you will not be getting anything, you can just mention that. I'll be considering it too. You can see the arrow outward, the arrow inward. The arrow outward, the arrow inward. So in this case, what you want to send away, what you want to throw away, what you want to keep like in or around your surroundings. So there are two things, N and P you are dealing with in the transistor. Okay, NPN transistor, you know, N type and the P type, but here I am gonna consider them as negativity and the positivity. Okay, instead of N and P type semiconductor, let's take that as negativity and the positivity. So negativity we try to throw away, or the positivity, negativity we try to throw away, or we want to keep it away from ourselves. Okay, so in that case, this is what? This is for N, negativity, N, P, N. And positivity you want to keep in, so, or around you, so N, P, N. Oh, that's going to be P, N, P, positivity inside, and that's how you are going to get, this is the PNP transistor you will have. Please tell me, is it alright and clear to everyone? Say yes or no. Done? That's the way how you can consider what type of transistor it is. Instead of just taking it as N and P, let's take it as negativity, go out, positivity, come in. So negativity, that's going to be N, P, N. Positivity, that's P, N, P. Okay, I hope you are getting that, and it will be quite simple and easy for you to consider it too. One more thing, maybe somebody will be there in the class right now who will say like, oh, it's very easy, just by looking at the symbol or the representation I get to know about it, why I should go for this way, okay, or this method to consider whether it is NPN or PNP type. So basically guys, you have to consider it this way. It's not necessary you have to consider it this way, but there can be some of the students, those who find it difficult to relate, those who find it difficult to consider, and for them I think it can be the easiest way to get this, that when it will have outward arrow and when it will have inward arrow. Okay, so it will make it easy for you. Negativity, go out, positivity, come in, and that's how you are gonna relate it. I hope it's getting clear. Along with these symbols, I would like to show you an important expression or relation in terms of transistor, okay, or for transistors, which is applicable, okay, and how we will be having that relation, we will talk about it. But before that, I need to make this symbol as well as the other representation for a transistor I need to show you. Okay, so let me just make it and then we will talk about it too. Which one is this? You are sending or you are throwing it out? Which one is this? I hope you can easily identify it. Even if you were finding it difficult earlier, now it should be easy for you to consider. The second one I'm gonna make here. Inward. What is this? The first one, first of all, you can mention, and then for second one, which one is that? Are you able to identify now? If yes, that's great, but if no, I'll be telling you, or I have already told you about that, so it should be clear. But still, if this is difficult, revise it. It will become easy. So generally the corner or the side sections, we make them equal, while I have already told you which one should be the greater one and which should be the smaller one, or which should be the in between both. Okay, so this is what negativity go out, so it is what Npn type. Npn. Positivity come in, Pnp type. I hope it's getting clear, but in case if there is any doubt, you can let me know about it. And if everything is clear, that's great. Okay, I hope it's clear. Now you know that Npn, what will move from N to P, electrons or holes? I have already explained some of the points here, so I just want you to tell me right now whether electrons or holes, which one will come or go from N to P side. Can you please tell me? If you can mention it in the comments. What will move from N to P in the first one, in case of first one? Anybody is getting it? If yes, mention that. If no, I will talk about it. I have already explained some of the points, and the further discussion is just based on that. That's why I was asking you, I was asking you to just mention it, what will move from one to another place. So basically, if you will see here, you can consider that electrons will move from N to P side. Okay, electrons will be something the emitter will emit. So if electrons are moving in this direction from N to P, very good Shubhankar. So what should be the direction of current? Can you please tell me? Outward from the corner part, I am saying outward or inward? What should be the emitter current direction? Outwards or inwards? If from N to P the electrons will move, so direction of current in the emitter section or through the emitter section should be outwards or inwards? Can you please tell me? Emitter current, outward or inward? Very good, Arpit. Shubhankar. The electrons move, or the current will flow in the opposite direction of electrons motion or movement, or you can say electrons movement will be in the opposite direction of the current flow. So if electrons are moving from N to P that way, the direction of current will be outward. Is that clear, Shubhankar? One more thing, even if you are finding it difficult for you to consider, in the symbolic representation, you can consider it with the help of the arrow. You can show, observe there. So direction of emitter current will be what? I.e. outward in the first case. Is that clear, Shubhankar? And to everyone, is this clear? In case if there is any doubt, you can just mention it. While you know what will move from P to N. Okay. Other than that, if I'm going to talk about the next thing, the direction of currents for P and for N type, what it will be? It will be upward for base, that is IB, and it will be this way for IC. In case if there is any doubt, anybody will have, just mention it, I'll be considering that. Same way in case of P and P, what you have to take? You have to consider it this way, that is IE, and for this one it will be IB, and this one IC. If there is any doubt, you can tell me about it. So basically it's gonna be, you know, as per the KCL, okay, you know it is applicable on the junctions, and we can have the sum of currents leaving from a junction and entering to the junction equal to each other. So you can say leaving one here is IE and entering ones are IB and IC. And you also know that the emitter is the heavily doped section out of the all three. So in that case, the emitter current will be the largest one, and due to which you can even see in terms of current leaving and entering, okay, or heavily doped section. So in that way you are getting the relation, that is IE is equal to IB plus IC. That is emitter current is equal to the base current plus the collector current. Same way in the second section, if you will see, emitter current is the entering one, and the base current and the collector current, these are the leaving ones. So again the entering one is emitter current and the other two are the leaving currents. So what you have to do in this case, you will say the IE, the entering one, is equal to the both leaving one, that is IB plus IC. In case if there is any doubt anybody is going to have, just mention it and let me know about it, and we will try to consider that point too. But if everything is clear, that's great. We will be considering some more points after this discussion. And till now, whatever I have considered here, if you are not getting any point, if you are not getting anything which we have considered here, just mention it. I'll be talking about that too. One more thing guys, this relation which we have derived just now, we have observed just now, that is IE, that is emitter current, will be equal to the base and the collector current sum. So that is important, and that's something which will help you at lots of places to derive many other expressions too, and to know about many other important formulae related to transistors. So this is something very important, even if it's basic. Okay, Shubhankar, like we have talked about IE. Okay, so as per the electrons movement, electrons will move from here to here. Okay, so in that case the direction of current should be what? IE should be in the opposite direction of motion or the movement of electrons. So you know N-type will have the majority charge carriers as electrons. Done. So in that case electrons will move from the emitter to base. So what will be the direction of current? Opposite. So that is what? That is this way. While if you will consider PN junction, what will move from here to here? That's what? You will consider, you are going to keep it the forward biased. Okay, that is negative side and the positive side you will have. Then this way you will have the connection. So you know that what will be the movement. Okay, so again what the collector will receive here, that will be electron it will receive. So electron, when it will receive this way, what should be the collector current? It should be this way. Okay, so you can consider the movement of electrons and you will be taking the direction of current opposite to that direction of movement of electrons. Shubhankar, is it getting clear to you now? Either consider it this way or you can take it as per the biasing too. Okay, anyway you can consider it. But if you will consider it in terms of majority charge carriers and the movement of electrons, it will become more easy to you, okay, to consider. That's great. Even at any other point you will have any doubt, you can just mention it and I will be talking about that too. Now other than this discussion guys, the next thing we will be considering here is the different connections, okay, which we can consider in case of transistor. So what are these different connections we can have and which we have to consider to derive more important formulae and to get the important expressions related to transistors. So the first connection we will be considering here is the common base connection. This is something very important and this is something you can't miss. Okay, so let's talk about the common base. Just a second. Connections. Let me just consider it here. And then we will talk about the important expressions related to common base connections. Done? Common base means what? What is the meaning of this thing? Can you please tell me if you know about that? If you don't know, I'll be explaining it. Don't worry then. But I want to know, are you having some idea about the common base connection? If yes, just mention it. I'll be considering the point you will mention there as well. or if you will be saying something which is not correct or which we can't consider, I'll be telling you the right thing then. So I want you to tell me, what do you know about the common base connection, or do you know something about the common base connection? Are you having some idea about it? If yes, surely mention that and I will try to consider it then. If you don't know anything about it, don't worry, I'm gonna explain that. So I'm just gonna wait for your reply first of all, and after that I'll be starting the further discussion as well. Okay, Shubhankar has mentioned one thing there, that base is grounded and that's why we call it the common base. Okay, I'll be considering that point, Shubhankar, while I'll even tell you that what is the meaning of this thing. Okay guys, the general thing about the common base connection you can consider here is that the base will be common on the input and the output, both the sides. That is the meaning of common base. Common base. Base is common on the input and the output, both the sides. I hope that's getting clear, but in case if there is any doubt you will have, I'll be surely considering that then. So I'll be showing you the circuit for it first of all, and then we will be driving, or we will be considering the more important things here. Just give me a second, I'll be proceeding further and we'll talk about it. Which type of transistor I'm gonna consider right now? If you are getting it, just mention that in the comments. Very good, Shubhankar. It is Npn type. That's correct. So here we will provide the input signal, okay, or any signal you want to send. That is something you will give here. This is Npn type. That's correct. Now, if it is Npn type, I have talked about the connections. Which one should be, or which section should be forward biased, which section should be the reverse biased. So can you please tell me, should I consider the positive side of the battery here at the first point, like here, or the negative? According to you, what I should consider to make it what we have considered it should be? Here I am asking here what I should consider, the negative side or the positive side of the battery, the polarity, what it should be there. Can you please tell me? Positive. Okay, we'll be talking about it. Negative, that's correct, because NPN type na, so N means negative, so negative should be connected with negative to make it the forward biased, and to make the other side the reverse biased if we want to consider. And since the resistance is more for that section, because that is reverse bias condition, we are going to take negative, positive, negative, positive, negative, positive. So basically that should be the connection we have to consider there. Okay, I hope you are getting it, but if you are not getting it, tell me. I hope it's clear. Done. What do you have to do next? So basically guys, here you know the direction of current. I have already separately considered that point. This is emitter current direction. This is base current, that is IB. This is collector current, that is IC. You know the important relation, that is IE is equal to IB plus IC. That's the important relation we will have. Okay. Now this is the Npn type transistor I have considered here. If I will take Pnp type, same way I will be doing the connections there as well, and we will be considering the forward bias and the reverse bias condition in the same manner as we have talked about it during the discussion. In case if there is any doubt anybody will have, then surely mention it and we will be talking about that too. But if everything is clear, that's great. That means we can continue the discussion. Abhishek, for both, even for interview it's important or for exam it's important, because in interviews even sometimes they ask for the derivations, how well you know about the topic. So interview is not limited to only formulae or only some part of your preparation, but it requires the depth and the detailed knowledge about the topics as we are doing the discussion right now. So it is important for interview as well as to solve the questions. If you will have a better understanding with the topic, you will get the clear idea. So it is important for the exam as well. Okay, hello Shina. Done. I hope it's clear to everyone now. Now let's move forward and let's talk about the other things. So NPN transistor case, if it is clear, same way PNP we will take the symbolic representation as we have considered for PNP, we will be taking it that way. To make the emitter diode forward bias, we have to consider the connections that way. To make the collector diode forward reverse biased, we will be making the connections in the similar manner as we have considered them. Now once you got to know about the circuit diagram of the common base connection, what is the next thing we have to consider here? Let's talk about that. Okay. Okay, Abhishek. So even for that you have to go for the details about the topics, and I think for the quantum section, if you want to go for like more details about the topics, you want to prepare them in such a way that they will be helping you for interview. So you can refer like if you want to go for books, I can suggest you the books by Jaitley and by Griffith. These are the different two books we are gonna have. Any of them you can consider, they will surely be helping you. They are the standard reference books. Even they are something which will provide you all those details and the depth knowledge about the topics whatever you need to have. So that can be helpful if you want to prepare these topics right now. Okay, you can refer these books too, or if you were just looking for the sessions, so you can even find them. Okay, there are many sessions we are going to have on important topics that will even be helping you. Shina, if you are not able to get the solution of the questions, okay, I would like to tell you something here. So see, it's not something you can expect it to happen just with, like, if you have prepared for some time till now, for example, or anybody has done the preparation for some time till now, okay, not for so many months, or has not solved so many questions, or has not prepared the topics in depth or detail as they should. Okay, there can be different like reasons for this thing, that why they are not able to solve the questions. If I'm going to talk about this thing, so the first thing is that you should consider, okay, all these points. The first one, are you having the good knowledge about the topic? If the answer is yes, next thing you have to check out, when you are reading a question, are you able to get that what is the concept involved in the question, from which concept the question is there, What are the important things you are going to have related to the question, okay, which you can relate with that question or its concept, you can relate there. So these are the things you need to firstly check out. If you are finding that you are not even able to relate the concept, or you are having some difficulty in relating the concept, then what you should do? Then in that case, you need to prepare the topics first. You need to gain more knowledge about the topics, or even if you have prepared them, now do more revision, okay. So in that way, by doing revision, by spending more time for those topics preparation, you will have better understanding with the topics, and it will make the things quite simple, easy and clear to you, okay. One more thing, if you are able to relate the concept but still you are not able to solve the question, so what you can do in that case? In that case, you need to practice more and more questions. Maybe there can be some issue with the calculation part. Maybe there can be a fear inside you that you can't do it, or you are not taking the next step even after relating the concept. So if that is the situation, by working on the questions, more and more questions, you will be able to overcome that fear that is stopping you to take the next step to solve the question, stopping you to move towards the solution of the question, okay. So by working on more questions, you can overcome that situation, and I think it will be helping you a lot. Instead of worrying about it, you have to work for it, okay. And what is that work you can do, or which will help you to improve? That is, make your targets for every day, okay. So what can be these targets? These can be related to solving few questions in a day, means 10, 20, 25, 30, 50, 5, 10, 8, any number of questions, okay. But make a target that every single day you will work on those questions. Just finalize the time you can devote for doing revision for the topics you have covered, more important concepts involved in the questions, so that can even help you to master this thing, that is how to relate the concepts, how to solve the questions. Slowly you will see like the things are gonna get changed, but we can't expect the things to get changed like just in a moment or just randomly anytime. No, if we will work for it, if we are gonna work on all these things, it will change. It will maybe taking some time, but still with time you will see the improvement, and you have to work for it, okay. If you are doing that work, that's great, you will soon see the improvement, okay, and you don't need to worry. Shinna, you can do it even if you are attending the courses I have conducted, the sessions I have conducted. Just check them again, okay, if still you are facing difficulty, because you know even there are many students we are gonna have in the sessions. So if others can get everything clearly, you can even get it, you can even do it. If like you have mentioned like the word like dull or this, it's nothing like that. It may need some more work to be done from your side. It may need more efforts, means solving more questions, doing more revision. So instead of worrying, what I have told you, stop worrying but start working. Clear? So right now, even as you have mentioned that thing, you are worrying more about it, but you have to work to improve from zero to hero. If somebody is going, then how are they able to go just like that? Or if even you have completed a topic and you are still facing difficulty, so that means that you just need to complete it once. Maybe you need to do more revision, because revision will help you to make a better command on the topics and to have a better understanding with the topics. So you are the only one who can do it. You are the only one who can change the way you are considering the problems. You are the only one who can make a great change in your like skills in terms of doing mathematical calculations easily. So if you will work on more questions, you will be able to see that how easily you will be able to solve the questions, the other questions, or you are able to tackle the mathematical problems, okay. Now you have to see where is the problem. Is it in relating concepts or in getting the concepts? or is it in the calculation part? Like your main question was that you are not getting the solution of the questions. Clear? So the main thing you have to understand first, reach to a conclusion, where is the problem, okay? And if you are reaching to the conclusion, if it is a problem in relating the concepts and you are not getting the concepts involved in the question, you are not getting from which topic the question is, that means you have to do more preparation or more revision of the topics. Okay, because generally the previous year questions or related questions based on the topics you have completed, if you are doing them, so at least you should be able to relate the concepts. But if you are not able to do it, do more revision, your problem will get solved. I have given you that solution. If you are finding that it is a problem in terms of doing calculation and that's the reason you are not reaching to the solution of the question, do more questions, work on the calculation part. So any of these issues can be there, whatever is that, firstly identify it, work on it, get the solution. Like I have already suggested the ones from my side. You can see if they can work for you, you can follow them, and that's the solution for your problem, okay, which you are facing, and I think it will be helping you too. Done? Okay guys, let's continue. In case still if you will have any doubt, difficulty or anything you want to ask, you can mention it. So this is the common base connection. Why it is common base? The reason behind it is that the base is common on the input and the output sides. The base is common on the input and the output sides. Okay. If the base is common on input and the output side, this is the input side, the base is involved there. This is the output side, the base is involved there. This is the base, this is involved there. So that's why we call it the common base connection. Once you are getting to know about it, what do you have to do next? The next thing is you have to work on finding the current amplification factor. Okay, current amplification factor. I have to consider the circuit once again, just a second. Or if you have already made it, you can just consider that on your own. Abhishek, that's great, Shina. Abhishek, for that you can just check this eligibility criteria for professorship. I think if you will have the PhD, it may not be needed, or if it is needed, like at least when you will get the admission for the PhD, okay, with your gate score, you will have more time to do that net exam, to clear the net exam, okay. So I think still you should go for the PhD if you want and you are gonna go for it, because if it will be required you can easily clear that exam later on. But if it will not be required because you are having PhD later on, you will have that, okay, then that's great opportunity for you. So for that you can check out few more things, because I may not be able to clear it right now. I even need to just go through that part, that whether it will be needed or not. While if somebody clears the net JRF now and they go for PhD, so I think that's not needed. The LS section is not needed, okay. And if you go through GATE, it should not be the case, but still, to get sure and to get confirmed idea about it, just check it once again. Okay guys, so the first thing we will find here is the current amplification factor as per this circuit. So what is that current amplification factor? Let's talk about it. In this case, we will be showing the current amplification factor. This is the common base connection. Okay. So current amplification factor in case of common base, we show it with alpha. What is that? You know the output side current is related to the collector. Okay. And the input side current is related to the emitter. So in this case, the current amplification factor, if you will consider it as per the change in current, so you will say delta IC, that is change in the collector current, that is output part. Amplification will be related to what? The output to the input ratio. So change in collector current to the change in emitter current at constant, okay, VCB or VCC, which I have taken here. So if I am calling it VCC, I will say at constant VCC. Okay, if you will take this value constant, then corresponding to that, whatever ratio you will get for the change in collector current to the change in emitter current, that will be what? That will be your current gain. Okay, that is delta IC upon delta IE at constant VCC will be the current amplification factor for the common base connection. Now in this case, you know ammeter current will be very much greater than the collector current, or it will be greater than the collector current, because you are having the idea about the relation, that is IE is equal to IB plus IC. So if you want to write delta IE will be equal to delta IB plus delta IC. So you know IE alone equal to the sum of IB and IC, which means IE is greater than IC. Okay, it means that the ratio will have the value smaller than 1, okay, or less than 1. So if the ratio will have the value less than 1, what is the meaning of that? It can have the value less than unity. So the current amplification factor in case of common base connection will be less than unity. The reason I have told you. Other than that, the practical values of alpha can lie from 0.9 to 0.99. The practical connection of this type of transistor will have the current amplification factor in case of common base 0.9 to 0.99. It cannot lead to 1. Okay, so let me know, is it alright and clear to everyone or not? If in case there is any doubt anybody will have, surely mention it. I'll be considering that. Hello there. Done. And if everything is clear, that's great. That means we can again continue the discussion about some more points, and we can talk about the next point here. Done. Once you got to know about the current amplification factor alpha, that is equal to delta IC upon delta IE at constant VCC, it will be equal to 0.9 to 0.99. Other than that, if I'm gonna talk about the next thing here, that is the collector current. The next parameter you have to find for the given circuit, that will be collector current. Now, how you will get the collector current and what will be the expression for that? Or what are the other things you need to know about the collector current? I'll talk about it now. So before I'm going to talk about the collector current, I want to tell you one thing here about the collector current. If you will consider there is no current or no signal on the emitter side you are providing, there is no signal on the emitter side. Okay, still in the circuit, practically if you will check it out, when there is no signal on the emitter side or no emitter current is there, in that case still you will get some of the collector current if you will measure it. If you will measure the collector current, you will be finding some of the collector current there. Now what is that collector current known as? When there is no signal or no value of current on the emitter current side, still we get some value of the collector current. Okay. Shubhankar, both are good at their places, but like depending on what you are planning for your future, okay, what you actually want for your future. So, on the basis of the scope of both of them, okay, that whether everywhere you can apply for the post, for the position, whatever is gonna be there after a particular case, okay, or you are interested in doing PhD. So if yes, then I think integrated PhD can be good for you. But if you want to think about it later on, okay, and you just want to do M.Sc at the time, so in that case you can consider the later one you have mentioned, but still you can just see if there are some of the changes in terms of accepting the like integrated PhD and then M.Sc and PhD separately. So you can see the differences, you can see the scope further, and then you can decide which one you want to go for. Okay, while everybody can have a different choice in terms of their situation, what they want to do, what is more better for them. So you can just have a look at it. Both are good at their own places, but still just go through like some more points regarding them so that you will be able to decide it well that which one you should go for. Okay, hello Chandan. Okay guys, let's talk about the next point now. So basically in this case, one thing I have told you is the collector current is still there when you are not providing any of the emitter current, okay. So that will be considered as the leakage current, okay. This will be considered as the leakage current. Now what is the leakage current? When no signal or no current was towards the emitter side and still you are getting some output. But if there will be some emitter current, then what will be the collector current you will have? That will be alpha times IE. What is the alpha? That is the current amplification factor. So alpha times IE you are getting when IE is there. When IE is not there on the emitter side, still you are getting some current, you are calling it the I leakage or leakage current. So in this case, you can say that the collector current is the sum of two currents. That is alpha IE plus I. You can write either I leakage or you can write CBO. You know collector, base and emitter are there. So whatever has been kept open, you have to keep or you have to write the O at its place. Instead of writing E notation, we have taken O because the emitter is open. So I, C, B, O. That's how you are going to consider it. If it is not clear, tell me. If it is clear, that's great. Now what is your target? Your target is to find the collector current. So what you can do, you know IE is equal to IC plus IB. We have already talked about it. Just put that value. ICBO itself is the I leakage. So IC is what? 1 minus alpha. IC, that is the collector current in this case, will be what? Alpha IB plus ICBO upon 1 minus alpha. I hope you are getting that. If yes, that's something you are having as the collector current. And if it's clear, that's great. But in case if there is any doubt, just mention it. I'll be talking about it too. Okay. And if it is clear, that's great. So that is final expression for the collector current you will have. That's how you can write it, and you can write your final expression for the collector current in case of common base connection. Once you got to know about it, the next thing you have to consider here will be the input and the output characteristics of the common base connection. Okay, input and the output characteristics of the common base connection. Now what will be the input characteristics? Let's talk about that first of all. Input side we will have emitter current and we will have the emitter base voltage. So it's gonna be emitter current and emitter base voltage means VEB. Okay, VEB, that is what? The emitter base voltage, that is VEB. In this case, if you will measure the VEB practically when we measure it now, so in that case we get the IE, that is the emitter current we will be providing or having as in terms or in units of milliamperes, while this one in millivolts, and the type of characteristic or the graph you will get is something like this or something like this. Okay, and here just a second. Once again I'll try to draw it. Here we are keeping the CB, collector base voltage, constant. So if you will, you can even call it the VCC. We have taken the VCC notation there. So when you are keeping this voltage constant, whether you are gonna set it at 10 volts or 0 volts, you will be able to see the relation between the ammeter current and the ammeter base voltage this way. Okay, where you have kept the VCC or VCB constant. In case if you are going to have any doubt anywhere, you can just mention it. I'll be considering that and I'll be talking about it too. But this is the type of graph you will have, and this is known as the input characteristic, because you know on input side we are having the ammeter and the like the presence of the this value, that is ammeter base voltage. So what will be the ammeter base voltage? This side voltage, which is between the emitter and base. Okay, so that's how you will be able to find the characteristic. It's important to know even about the graph, because you can get the direct questions from the graph. Other than that, you should also know about the input resistance. Now what will be the input resistance? That will be the, you know, V is equal to IR, so R is equal to V upon I. So you can say delta V EB, okay, which you are having here, or BE, upon delta IE at constant VCB or VCC. That's how you will consider it, and that's your input resistance, which is the ratio of voltage and the current. Okay. Yes, Shubhankar, ICBO was what? ICBO was I leakage. What is the leakage current? Leakage current is even when you will not have emitter current this side, or when you are not considering any emitter current, still you will have some of the collector current on the other side. Okay. Now what is that collector current if there is no emitter current? That is, if practically you will check now, we are going to have labs in our college. So if you will do that practical and you are not having any emitter current at any moment, still you are having some collector current. So that collector current is known as the I leakage, that is leakage current. Okay, or you can give it the notation ICBO. What is open? Emitter is open there. Other than that, you can consider one more thing. What is that? That is simply that if we are going to have the emitter current present there, then what we get? We get the alpha times emitter current as IC. So alpha IE is equal to IC or I leakage. Both are the collector current. Okay. So the sum of both you will take as the overall or the total collector current. Please tell me, Shubhankar, is that clear to you now? So practically if you don't provide any IE value, still you get the IC value. Do you call it the I leakage? When you provide the IE value, you get the IC as alpha IE. So the total, even that I leakage will be present at that point of time. So your collector current will be what? That will be alpha IE plus ICBO. The total sum of both the currents you are taking there. In case still if you are going to have any doubt, just mention it. I'll be talking about that too. And if it is clear, that's great. Now, after considering all these things, you have to go for the output characteristic. Okay, now what is the output characteristic? On the output side you will have the collector present, so the collector current and the VCB, the graph between them, will be considered as, that is IC in milliamperes. Just a second. And VCC, the graph between these two. Okay, we get this type of graph. So IE is equal to 0 milliampere. You keep the emitter current constant here. Okay, emitter current constant here. Now let's talk about the next thing. So if we are going to talk about emitter current, it can be 0 milliampere, 1 milliampere, 2 milliampere or 3 milliampere. In this case, we also need to know about the output resistance. That will be equal to delta VCB or VCC, okay, upon delta IC at constant IE. That is what? That is going to be your R0, that is output resistance. In case if you will have any doubt anywhere, you can tell me about it and we will try to consider that point too. But if everything is clear, that's great, okay. And still, if you are not getting something clearly or something is not getting clear to you, just mention it. Other than this, you have to go for the next circuit or the next connection, that is common emitter. If it is clear till this point, that's great. We can go for the next connection. So that will be common emitter connection. This time the emitter will be common towards the input and the output, okay. On both sides it will be involved, and this is the more frequently used connection or the type of circuit we will have, which we generally use, we need to use, we can expect the questions based on it. That is common emitter. While the common base is even important, but practically or like at most of the places we prefer to use common emitter connection. As we will be proceeding further to do rest of the discussion, you will get to know what is the reason behind it and why we use it most of the time. What is the reason? Okay, everything will get clear to you. But before proceeding further, I would like to ask you, in case if you will have any doubt or something is not clear to you, just mention it, let me know about it, and I will be trying to consider that as well. And if everything is clear, that's great. Okay, we will be making the circuit diagram for it first of all, and after that we will proceed further for the further discussion. So I will take the NPN transistor to make the connections. Okay, same way, by making that forward and reverse biased connections, you can make the PNP circuits too if you want to make it anytime. This time you can see the emitter, this arrow side is the emitter side. It is common towards the input and the output sides. It's present there. Excuse me. Okay guys, we are going to have this connection as a common emitter connection. This is the input side, the emitter is involved. This is the output side, the emitter is involved in that part of the circuit too. Now the next thing is, once again we have to find the current amplification factor first of all, and here in this case we represent it with beta. In common base we represent the common like the current amplification factor with alpha. It's not necessary always you will be representing with the same notation. You can even have the different notation given to you for that. Other than that, in case of common collector or like ammeter, you are going to take it as beta, and in case of common collector we take it as gamma. Okay, so common ammeter connection, now we'll be considering it as beta. What it will be? The current amplification factor, so delta IC, the output side, upon delta IB, that is the input side. Because ammeter is common this time, so it will not be something we will consider here. So that's how you can say you are going to have the common emitter connection current amplification factor. Other than that, what you need to consider, because you know IB is gonna be very much small, okay, in comparison to IC, even the base current is very much small. So the value of beta can range from 20 to 500. Okay, the gain, the current amplification factor can be having the value lying between 20 and 500, 20 to 500 somewhere. So that's why its gain or the amplification factor is high. While in case of common base, what you have got, it was 0.9 to 0.99. So that was the range, which is like less in comparison to the common emitter connection, which will have the amplification factor value lying between 20 and 500. So that is one of the reasons why we prefer to use the common emitter connection instead of common base connection. Okay, so I hope it's getting clear, but instead, like, still if you will have any doubt, you can just mention it and let me know about it. But if everything will be clear, that's great. Now there comes the next point, which is what is the relation between alpha and beta. What is the alpha we have taken? In case of common base connection, what is the current amplification factor? That is alpha. So the relation between alpha and beta, if you want to find, you know this is the beta expression. You know alpha was what? That was delta IC upon delta IE. Okay, this is alpha, this is beta. And you also know IE is equal to IB plus IC. So if you will write in terms of delta, so delta IE is equal to delta IB plus delta IC. What you need to do next? The next thing you can consider here is delta IB is equal to delta IE minus delta IC. Just find the delta IB value from here. What will be delta IB value? That will be delta IE minus delta IC. Clear? Just put this value here at this place of delta IB. If you will put it there, what will be the beta value you will have? That's gonna be delta IC upon delta IE minus delta IC. Okay, that's how you can write it. Once you are going to consider it this way, just divide the numerator and denominator with delta IE. Reason behind it, you already know that you had the alpha as delta IC upon delta IE. So if you will divide the numerator part with that, it will become the alpha expression. Okay, so it will give you alpha upon delta IE upon delta IE, that's 1. 1 minus delta IC upon delta IE, that's again alpha. So beta is equal to alpha upon 1 minus alpha. That's what you will be getting. If still you are gonna have any doubt anywhere, you can just mention it and let me know about it. And if it is clear, that's great. Okay, this is the relation between beta and alpha. What is beta? Beta is the current amplification factor in case of the common emitter connection. Alpha is the current amplification factor in case of common base connection. Okay, so if it is clear, that's great. But if there is something which is not clear to you or wherever you will have any doubt, just mention it. We will be considering that point too. Now let's talk about the next one. So after this, you have to again find the collector current in this case, like we have done in case of common base connection. We'll be doing the same thing for the common emitter connection too. So what it will be? see, to find the IC, you will firstly be considering the same relation, that is IC is equal to alpha IE plus ICBO. Okay, ICBO. Now what you have to do next? You have to consider the IE value, because your aim is to get the IC. So you can't replace it, but you can put the value of IE, that is IB plus IC plus ICBO. That's what you will have done. Now just take the value of IC on the other hand. That will give you IC 1 minus alpha, that is equal to alpha IB plus ICBO. In case if still there is any doubt, just mention it. Next is IC is equal to alpha upon 1 minus alpha IB plus 1 upon 1 minus alpha ICBO. The same relation we have got earlier, we have got the same relation here as well. This one, alpha upon 1 minus alpha IB plus ICBO upon 1 minus alpha. If there is still you are gonna have any doubt, just mention it and let me know about it. Next thing, if you will say that there is no base current this time, because the base is on the input side this time. So if you will say no base current is there, means you have to take IB 0. Then the value of IC you are getting, what you will call it? You will call it ICEO, because base you have kept open and you are saying the base current is not there. So whatever we keep open, we don't consider that value. We don't write it suffix there. Okay. So CEO, which is equal to 1 upon 1 minus alpha ICBO. So this is the value you are going to get if you will consider the base open in this circuit, because that was on the input side. Okay, the main thing, not the common part you have to consider. Other than that, you can write it like this, that is ICBO is already there. If you will consider the value of ICBO in terms of ICEO, so you can replace this as ICEO. I hope that's getting clear. But still, if you will have any doubt, you can tell me. And alpha upon 1 minus alpha is what? That's beta. So you can write it as beta IB plus ICEO, that is equal to IC. If there is any doubt, you can let me know about it. And if everything is clear, that's great. Okay. So I hope whatever we have considered till now in this discussion, that will be clear to everyone. But still, if you are finding like something is not clear, any point, whatever we have considered, you can just mention it. I'll be considering that. Okay. So I'm gonna wait for your reply first of all, and then I'll be continuing the discussion about the characteristics, input and the output characteristics. We'll be continuing that discussion then. So let me know if still you are gonna have any doubt anywhere. Just mention it in the comment section. And if everything is clear, I'm just going to show you what will be the input characteristic graph. That will be the graph between IB and VBE. You will keep the VCE constant in this case. Excuse me. So it is going to be VCE is equal to 1 volt or 10 volt. Okay. So for both we have shown the graph so that you will be able to compare what kind of graph you will have if you are going to have one lower value and the greater value. This is 0. Okay. This is in microampere. So this is your input characteristic, which is the graph between IB and VBE. If you have to consider the input resistance, that will be delta VBE upon delta IB. You will have to consider this way. Other than that, if you have to consider the output characteristic in case of common emitter. So what it will be, I'm going to show you the type of graph you will have. That's going to be something like this. This way, this way, this way, this way. Okay. It is what? It is IB is equal to 5 microampere. That's something we are keeping constant. Okay. Still, if you will have any doubt anywhere, you can just mention it. I'll be considering that too. So basically you can make it this way. If you are gonna take this line now, this way, this way, this way, this way, this way. Done? That's how you have to make this. It is the graph between IC and VCE. IC and VCE. So guys, that's how you are going to make the output characteristic graph, or you will be getting it if you will draw it in case of common ammeter, and the output resistance will be delta VCE upon delta IC at constant value of IB. Okay, in case if you are gonna have any doubt anywhere, just mention it and let me know about it. But if everything is clear, that's great. That's great. Okay, so now we will be keeping it this much right now in this session, but if you want to ask anything, you can tell me, and I hope many things you got to know about the transistor today in this session. And if you want to ask something more, you want to ask something about the transistor related points which we have covered here, or even related to that, so you can tell me about it and I'll be trying to consider that point too. And if everything will be clear, that's great. We'll be keeping it this much right now. And thank you so much everyone for watching this video till the end, joining this session till the end. Okay, and let me know if there is something you want to ask or something is not clear to you. Otherwise, just revise the concepts we have considered here, because this was the basic part as well as the most important part, which you can't skip if you are gonna prepare the transistor topic, and you have to cover up this section. Okay, because it will be helping you to understand many things together and even to have a better understanding with the topic. Clear? Still, I'm gonna wait. If in case you are gonna have any doubt and you want to ask, you can just mention it. Also guys, as I have told you about one more thing here, that is soon there can be the price hike on the Unacademy subscription. So if you want to start attending the well structured and well planned courses by the top educators we are having on Unacademy for your upcoming exam preparation, then you can take the plus or the iconic subscription, that is Unacademy Plus or the Unacademy iconic subscription, so that after taking the subscription you will be able to start attending the live classes of well structured and well planned courses by the top educators. And by using and by applying the referral code, which is Anjali Arora or Anjali A Live, any one of these referral codes you can use and apply, you will be able to get the 10% discount in the total subscription amount. I would even like to show you that what are the plus or the iconic subscriptions meaning we will have. So basically, if anybody will be taking the Unacademy Plus subscription, they will get these benefits. If anybody will be taking the iconic subscription, they will get these benefits. One more thing, as soon there can be the price hike. So by taking the Unacademy Plus subscription right now, okay, because right now if you will take the subscription, you will be able to take it at the current prices. So you will be even getting the 10% discount in the total subscription amount. And in upcoming days, many new courses by the top educators will even be starting. So by taking the subscription, you can start your preparation under the guidance of top educators, and you can take your preparation to the next level. And whenever you will be taking the subscription, use and apply the referral code, which is Anjali A Live, as it has been mentioned here on the screen. By using and by applying this referral code, you will be getting the 10% discount in the total subscription amount, okay, at the same time. To take the subscription, you can download the Unacademy Learning app, or you can search Unacademy Plus on Google directly, and that's how you will be able to proceed further by selecting your goal. That can be CSIR UGC NET if you are doing the preparation for CSIR NET exam, or even if you are doing the preparation for any other exam, you can select that as your goal. After that, you will be selecting the subscription, whether you want to take the plus or the iconic subscription. After that, you will be selecting the duration for how much time you want to take the subscription. Then you can you will get a place to write the referral code. There you can write the referral code Anjali Arora or Anjali A Live, any of the referral codes. Okay, and by applying the referral code at the same time, you will be getting the 10% discount in the total subscription amount. By joining these important sessions by the top educators, you will be able to know about important tricks, concepts. You will be able to know about the right approach to solve the questions and many important things, which will help you a lot to take your preparation to the next level and to have the best preparation or the very good preparation for your upcoming exam. So I hope each and everything is clear to all of you guys, and thank you so much everyone for joining this session till the end. And I hope each and everything is even clear to all of you. So thank you everyone for joining this session till the end. Thank you.